If it lives up to expectations, this meteorite could reveal the exact chemistry of the dust grains that built the newborn Earth.
Meteorites are a window on the past. And they tell us something about the conditions in which the solid planets formed.
This particular meteorite is really special. In the first place, it has the highest carbon content of any meteorite, and the highest amount of these preserved interstellar stardust grains of any meteorite, and has a very high water content as well.
In addition, about 90 other elements have been identified. And already, they're providing a chemical fingerprint of early Earth. And within this meteorite are radioactive elements that decay at a precisely known rate, allowing scientists to calculate the meteorite's age. And since most meteorites formed at the same time as the planets, and from the same material, the age of the meteorite gives you the age of Earth and its neighbors.
If you date meteorites, what you find is that almost all meteorites have the same age, about 4.55 billion years old. They're all the same age. It's pretty monotonous. Within a couple of tens of millions of years to hundreds of millions of years, they all have exactly the same age. And so what we do is take the oldest of these ages and use that as the initial age of the solar system.
That narrow range of ages indicates that all meteorites and planets coalesced extremely quickly in the early days of the solar system. But Earth had barely taken shape before the first of several major disasters struck the young planet. Earth's gravity was pulling in huge quantities of debris from space. A continual bombardment that generated enormous amounts of heat on the surface. At the same time, radioactive elements trapped deep within the Earth were decaying, producing even more heat and roasting the planet from the inside. The combined effect was catastrophic. By 8 minutes after midnight on our 24-hour clock, the planet had become a raging furnace. And when the temperature reached thousands of degrees, dense metals such as iron and nickel in Earth's rocky surface melted.
The outer part of the Earth would have been completely molten. We call that a magma ocean. It's a liquid rock ocean, hundreds of kilometers thick.
Do you think the Earth at some point was a big droplet of melt just floating in space? When you have a totally molten object like this, the heaviest elements, and that includes things like iron, would sink to the center of this droplet. And the lightest elements, things rich in carbon and water, for instance, or light elements, would float to the top and float there like algae on a lake.
The global migration of the elements, known as the iron catastrophe, would have a profound effect on the future of our planet. The sinking iron accumulated at Earth's center, where it created a molten core twice the size of the moon. The liquid iron is constantly swirling and flowing. And even today, this motion generates electric currents, which turned our planet into a giant magnet with north and south poles. The core is still in constant motion. And we can see evidence of Earth's liquid iron core on the cold, snowy wastes of Arctic Canada.
Well, the magnetic field is constantly fluctuating on a minute-to-minute or even second-to-second basis. And one result of this is the fact that it causes the magnetic pole to actually move randomly over the course of a day.
Every few years, geologist Larry Newitt sets out in search of the precise location of the magnetic North Pole, or north on a compass. Newitt spends days at a time on the ice, in temperatures as low as minus 50 degrees Fahrenheit. The geographic North Pole is in a fixed position, but the magnetic pole is always on the move. Over the last century, its position has changed dramatically.
Get going.
To identify the pole's current position, Newitt measures the strength and direction of the magnetic field at about 8 different sites, then closes in on it.
89, 13.0. Since we don't know where the pole is, we can't just go there and take a reading. So we surround it, and then I determine its location by a process of, well, what amounts to triangulation. 268, 35.0.
At the time of the most recent survey, the pole had moved 125 miles off the Canadian coast. And Newitt and his colleagues have discovered something curious. Its movement is picking up speed.
Over much of the past 100 years, it's been around 10 kilometers per year. But since about 1970, it started to accelerate, and now it's moving along at about 40 kilometers per year. If this keeps up, it'll reach Siberia in about another 40 or 50 years. But of course, that's a rather dangerous extrapolation. We don't really know where it's going to go.
Without Earth's liquid iron core, life would be in trouble. This swirling ball of molten iron is what generates the magnetic field around our planet. And we need that magnetic field because every day, a deadly stream of electrically charged particles bombards the Earth. Ejected by the sun in monstrous solar flares, these particles hurtle through space at about 1,000,000 miles an hour, forming what is known as the solar wind. Some think that if the solar wind ever reached our planet, it would strip away the atmosphere. But Earth's magnetic field creates a protective shield that deflects these deadly particles. And you don't have to travel far to see the fate of a planet that lost its shield. 4 billion years ago, Mars had a liquid iron core and a magnetic field just like Earth's. Mars built up a thick atmosphere and supported liquid water on its surface. The planet may have even been home to primitive forms of life. But Mars is just a fraction the size of the Earth, so it cooled more rapidly. And as it cooled, its molten iron core hardened. As a result, Mars stopped generating its magnetic shield. And according to one theory, this left its atmosphere to be scoured away by the solar wind. Today, the surface of Mars is a barren desert. Mars is a stark reminder of what our world could have become if its iron core had cooled. Because without a magnetic shield, a planet is left prey to the solar wind, and life as we know it could never flourish. The time had reached 16 minutes after midnight. The iron catastrophe was over. But even with the formation of Earth's core and magnetic shield, our planet remained a hostile and alien world. Volcanoes spewed clouds of noxious gases,